We are undeniably alone in our subjective universes. We nevertheless reach across the objective realm to make contact with one another that makes its accordant impact within one another's minds. There is a well-worn conversation that takes place among certain kinds of friends to the effect of wondering whether the qualia one experiences are identical to those of the other. The most common application of this inquiry is to the perception of color. We ask, is your color red the same as mine? We mean by this something very particular. Of course, we recognize that objects in the world which appear red to me will also appear red to you. That is, the label red will, we agree, be the correct label to assign to what each of us is seeing. We've been exposed to such labeling since we first learned to talk and to identify objects and characteristics in English terms. One fish, two fish, red fish, blue fish. The question being wondered is whether what you experience in your private world when presented with such a red object is the same as what I experience in my private world. After all, if I am seeing what you call orange when I see something red, and you are seeing what I call green when you see something blue, we will not be able to discover this fact because of its subjective nature. You might argue that there is a distinctive difference between, for example, the perception of warm colors like yellow and red and the cool colors blue and violet. But couldn't that just reflect the fact that fire is composed of warm colors and the night sky or a lake appears in cool colors? Maybe we just associate the phenomenal color qualia with the objects that tend to exhibit them. So if I am seeing your green when I look at a fire, I will call it yellow or orange, just as you do, and I'll associate it with warmth. It seems to me that what we are really attempting to do here, between us friends engaged in such a conversation, is to know whether we can be secure in our similarity. How different and therefore alone should we feel? In this episode, I will take a look at qualia to begin to specify what they are, things that can only be known subjectively. I have defined qualia as meanings and argued that they occur as relationships among certain co-occurring neural activities in the thalamocortical system. Mostly, I'll be talking about color as a good example for our consideration. The question of the day is, do my qualia resemble your qualia? C.L. Hardin writes on the relations which colors have to other colors in the book Color for Philosophers. He describes the theory of universals by David Armstrong, which compares the class of shapes with the class of colors. Then Hardin writes, quote, "The perplexities about shapes can be effectively addressed by the devices of analytic geometry, which reduce questions about shapes to questions about equations. For example, we sense that circles are more like ellipses than like squares, and this set of similarities and differences is captured by the fact that circles and ellipses are represented by parametric differences in the same basic equation, whereas a square requires an equation of a quite different form. Furthermore, the difference between a circle and an ellipse is precisely represented by a difference in parameters, such that, as the parameters approach each other in value, the corresponding figures approach each other in shape. A more puzzling determinable-determinant relationship, that which holds among the apparently heterogeneous collection of objects, the shapes, is thus reduced to a less puzzling one, that which holds among an apparently more homogeneous collection of objects, the numbers. In a similar fashion, we can map the relationships among the colors into a set of relationships among vectors, reducing questions about the qualitatively heterogeneous collection of objects to questions about a qualitatively homogeneous set of objects." Unquote. This discussion is reminiscent of an idea which I have never really gotten across effectively when talking to people about the geometric relations of qualia. It seems to me that seeing the color blue, for example, is more similar to seeing the shape triangle than it is to hearing the note E minor. They are qualia of a quite different kind, but being the objects of perception, they also share a broader similarity. I think that neuronal circuit maps in the cerebral cortex are responsible for this. Indeed, raw sounds are handled by a different region of the cortex than our raw visual inputs. They emerge from activities in different topographical wings of the overall cortical architecture. But according to the temporally integrated causality landscape, all qualia occur upon a common landscape of conscious experience. By way of a crude analogy, let qualia be simple geometric objects that can be placed on a normal high school math coordinate plane. You remember the x-axis is horizontal and the y-axis is vertical, and you could plot points in 2 dimensions on the coordinate plane using one value for x and another value for y. Alright, so imagine that seeing the color blue in a certain area of your visual field places 3 points on the coordinate plane, say in the upper right quadrant, forming a triangle of some proportions. Seeing the color red in that same location results in a triangle of some proportions, but in the bottom left quadrant. These objects are shaped a little different and in different quadrants, but they are on the same plane. Since we are similar creatures, you and I, at least with regard to neuroanatomy and physiology, we can assume that you have such a coordinate plane for color perception, and I do too. The geometrical object showing up in the upper right quadrant of my coordinate plane might be a little different from yours, but it's essentially the same shape on essentially the same plane. We can imagine sound qualia as geometrical objects too, but these shapes are on a different coordinate plane. This other plane can have points and shapes on it, but it exists in parallel to the plane for color perception. Extending the analogy, for a synesthete, these 2 coordinate planes might not be fully parallel. There may be areas of overlap, or a place where the 2 planes cross one another, such that a certain musical note might give the sense of the color blue, for example. Patricia Churchland has a part in her book Neurophilosophy that I will share that is relevant to the topic at hand. In a section on color perception in the phase space model, she writes, quote, "The photoreceptors responsible for color vision are the cones, and a cone may have one of 3 types of pigment, with differing sensitivity to specific light wavelengths. The long wave cones are maximally sensitive to light at wavelengths of 450 nanometers. The middle wave cones are sensitive over a large range, but peak at about 535 nanometers, and the short wave cones, whose sensitivity largely overlaps with that of the middle range cones and partly overlaps with that of the long wave cones, have a sensitivity peak at 565 nanometers. The computational problem for the visual system is how to get reflectance efficiency, lightness values, out of values for light flux on the receptors. The representation problem is how a given triplet of reflectance values yields the representation of a unique color. It appears that this problem can be given a simple geometric solution. Once the system has obtained reflectance efficiency values at each of the 3 wavelengths, perception of a given color is determined by the relations among the 3 reflectance efficiency values. But what is remarkable is that, as Land points out, any specific color can be represented as a point in a 3-dimensional color space." Unquote. Remember, the currency of the nervous system is the action potential. Nothing about the stimulus itself is carried into the brain. But there are 3 different cone-type signals that can be used by the thalamocortex to manufacture the color qualia. Just as circles and ellipses are more similar than circles and squares, so orange is more similar to red than it is to blue, and all of the relationships are ultimately geometric. What might this imply about the resemblance of your qualia, given a stimulus, and my qualia, given the same stimulus? For you, the geometric adjacency between orange and red, as opposed to blue, stands in the same relationship as that geometry occurs for me. Thus, the meanings are the same. But that does not mean that I am experiencing the same phenomenon as you are. The same proportion, the same geometric relationship, certainly, but not necessarily the same precise qualia. Imagine a species of blind moles which emit 3 different frequencies of sound for the purpose of echolocation. Perhaps the 3 different frequencies serve to provide textural information about objects in the environment due to differences in their degree of penetrance and transformation before being heard by the mole's 2 ears. As I have described in a previous episode, the brain can distinguish positions in space because of the delay in arrival of the sound between the left ear and the right. Isn't it possible that the mole could experience a vision-like representation of its environment, complete with 3 dimensions of color? The color qualia, in this case, would have nothing whatever to do with photons. Instead, the color would correspond to the echo characteristics given by the 3 different types of vocalizations. You see, the relationship between color qualia and light in the environment is completely arbitrary. Color qualia are emergent from a neural arrangement. To ask whether an object in the world is actually blue in color is like asking whether a certain odor is blue in color, or a texture, or whether the sum of 2 numbers is more or less red than their subtraction. There is a thought experiment in the philosophy of mind originated by Frank Jackson in 1982, which pertains to a color scientist named Mary, who has for the whole of her life been confined to a black and white room. Jackson writes, quote, "Mary is a brilliant scientist who is, for whatever reason, forced to investigate the world from a black and white room via a black and white television monitor. She specializes in the neurophysiology of vision and acquires, let us suppose, all the physical information there is to obtain about what goes on when we see ripe tomatoes or the sky, and use terms like red and blue and so on. She discovers, for example, just which wavelength combinations from the sky stimulate the retina and exactly how this produces via the central nervous system the contraction of the vocal cords and expulsion of air from the lungs that results in the uttering of the sentence, "The sky is blue." What will happen when Mary is released from her black and white room or is given a color television monitor? Will she learn anything or not? It seems just obvious that she will learn something about the world and our visual experience of it, but then it is inescapable that her previous knowledge was incomplete. But she had all the physical information, ergo there is more to have than that, and physicalism is false. Clearly, the same style of knowledge argument could be deployed for taste, hearing, the bodily sensations, and generally speaking for the various mental states which are said to have, as it is variously put, raw feels, phenomenal features, or qualia. The conclusion in each case is that the qualia are left out of the physicalist story, and the polemical strength of the knowledge argument is that it is so hard to deny the central claim that one can have all the physical information without having all the information there is to have, unquote. Jackson's argument, which he marshals to support the conclusion that consciousness is epiphenomenal or non-functional, fails to convince me. It looks to me as if he is making the simple observation that knowledge refers to objective facts. There is a degree of ambiguity, however, when Jackson says that Mary acquires all the physical information there is to obtain about what goes on when we see ripe tomatoes or the sky, and use terms like red and blue. The ambiguity is with regard to knowledge. We can have more than one kind of knowledge. For example, I can know that I have children, which is an objective fact, but I can also know that I love my children, which is a subjective fact. A distinction must be made between all things physical and all things objective. Mary has all the physical information, but if she learns something new about color when she sees it for the first time, then, Jackson argues, she has learned something which is not physical. Therefore, subjectivity is not a property of physics. The problem is that when you read Jackson's argument, it is implied that the knowledge accrued by Mary in her black and white room is of an objective kind. This is implied because she is a specialist in the neurophysiology of vision, and we do not normally specialize in subjective knowledge. A specialist on Parkinson's disease is not expected or even encouraged to learn what it is like to exhibit tremors herself. But in order to make the thought experiment do its true work, we have to include all physical knowledge, objective or otherwise. We must accept that either subjective knowledge is a subset of physical knowledge or it is not. And if it is not, goes the argument, then consciousness cannot exhibit causality in the physical world. So the bit about acquiring all the physical information there is to obtain has to do some really heavy lifting. In Consciousness Explained, Daniel Dennett, who calls the case of Mary a bad thought experiment, says, quote, "Mary has had no experience of color at all, and so, at that special moment when her captors finally let her come out into the colored world, which she knows only by description and black and white diagrams, it seems just obvious, as Jackson says, that she will learn something. Indeed, we can all vividly imagine her seeing a red rose for the first time and exclaiming, 'So that's what red looks like.' And it may also occur to us that if the first colored things she is shown are, say, unlabeled wooden blocks, and she is told only that one of them is red and the other blue, she won't have the faintest idea which is which until she somehow learns which color words go with her newfound experiences." That is how almost everyone imagines this thought experiment. Not just the uninitiated, but the shrewdest, most battle-hardened philosophers. Only Paul Churchland has offered any serious resistance to the image so vividly conjured up by the thought experiment of Mary's dramatic discovery. The image is wrong. If that is the way you imagine the case, you are simply not following directions. The reason no one follows directions is because what they ask you to imagine is so preposterously immense you can't even try. The crucial premise is that she has all the physical information, unquote. Jackson's argument is circular. It hinges upon the implied claim that subjective knowledge is not physical knowledge, then claims that this is evidence that subjectivity is not physical. Looked at in this way, his starting premise is the same as his ending conclusion. If the thought experiment were laid out so that she had all objective knowledge, which is the way that most of us read the thing the first time through, then of course she learns something new when she sees color for the first time. She learns what it is like for her to see a color. Suppose you were an expert on a particular poet. You knew all their work. You have memorized every line they've ever written. You've studied their personal correspondence, and you know their life story from childhood to old age and the circumstances of their death. Could you know all there is to know about the poet? No, forget that. How about having all the knowledge of a particular poem? One poem. If we mean objective knowledge, then it's at least conceivable. But if we mean all knowledge, we are getting to a level of godlike omniscience. What was it like for one Seymour Levitz to have experienced the reading of the poem at the dining room table of his childhood home on Hillsbury Street in Newton, Connecticut on August the 4th, 1971? How about if young Seymour had read it an hour earlier? What would that have been like? When he read it aloud, what did it sound like to the parakeet in the next room? This catalog of knowledge would have to include all possible conscious experiencers in all possible frames of mind across all possible times and places. Together with all of the objective knowledge, you would have to have all of the subjective knowledge. That's a lot to ask of a poetry expert, and Jackson is asking an awful lot of poor Mary. So sadly, Mary hasn't learned anything new upon seeing color for the first time. This is for the same boring reason that God would not learn anything if he came to earth as the son of a carpenter. He already knows everything. So there. In fact, within the thought experiment, Mary would be the only one who could answer our starting query. She has all the physical knowledge, objective and subjective. So let's just ask Mary, is it the same to see red for me and for my friend? What about for bats? Do they see red? What about this Egyptian fruit bat? What about that Egyptian fruit bat? Him too? In the very beginning of this podcast, back in episode 1, I laid out my starting assumptions for investigating the nature of consciousness. I said that I assume the material world exists, that I exist, that other conscious beings exist, that consciousness arises from the brain, and that it does so by physical means. Recall that physics refers to everything in the universe, not just matter. I'm not saying, and neither was Frank Jackson, that physical means material. Physical might refer to time or space or gravity or energy or velocity or whatever. My whole project here is to try to come up with an explanation of consciousness by determining its relationship to the rest of the universe. If consciousness does not stand in relation to the rest of the universe, then consciousness cannot be said to exist. Well, we've been through this. I do exist. Of that I am sure. As for the rest of y'all, I'm crossing my fingers.